Okay, arithmetic sequences and series review. So we have terms in a row. So we have 1a. So this means that we have the term 4, comma, blank, comma, -2, comma, blank, comma, blank, and find the missing terms. So obviously we can just logically do it, thinking about how you get from 4 to -2 in 2 steps and think about the difference, but we want to think logically about it. We're going to take 4 plus the number of differences away. So that's 2 differences, so plus 2 differences is equal to -2. If we subtract 4 from both sides, 2d equals -6, and divide both sides by 2, and d equals -3. So if the difference is -3, then we're going to have the terms 4, and if we're going down by 3, 4 minus 3 is 1, minus 3 is -2, which we got as we expected. That was the goal. -3, -5, -3, -8, and there is our sequence. So very helpful using a formula whereby you take a term and add the number of differences away to get the next term. That will avoid a whole bunch of systems of equations. So a very helpful tool in finding terms in the future. Okay, we have 1b. So we have 5, comma, blank, comma, blank, comma, 20, comma, 25. So this time we don't have to. We know that the terms just go up by 5. So we can simply just go back by minusing 5. 15, minusing 5. 10, minusing 5, done. We could have done 5 plus 1, 2, 3d equals 20. Subtracted 5 from both sides. 3d equals 15. Divided both sides by 3. d equals 5. Then we could have taken the first term 5 and added 5 to it, the difference 10, added 5 to it, the difference 15, and made sure that we got the terms that we wanted. So we can use logic, we can use that formula. Again, we could have used the systems of equations, but that would be very difficult. Okay, so we have 1c. So we have 13, comma, blank, comma, blank, comma, blank, comma, 81. So we have the first term, 13, plus 1, 2, 3, 4 differences equals 81. If we subtract 13 from both sides, 4d equals 68. And if we divide both sides by 4, 68 divided by 4 should be 17. Good. So d equals 17. Then we have our sequence. So we can say 13, and then if we add 17, we're going to get 30. If we add 17, we're going to get 47. If we add 17, we're going to get 64. And if we add 17, we're going to get 81. Okay, we have 1d. We have terms blank, comma, blank, comma, blank, comma. So we have the terms x plus 1. We have the terms 3x minus 1, and we have the term 5x minus 3. So we need to find the next 2 terms. So we're first going to find the difference. I'm going to clean up that 3 a tad. So we're first going to find the difference. So d equals taking a term and subtracting the term before it. So we have 3x minus 1 minus x plus 1. So d equals 3x, distribute the negative, minus x is 2x, and negative 1 minus 1 is negative 2. Let's find the difference again. D equals 5x minus 3 minus 3x minus 1. D equals 5x minus 3x is 2x, negative 3 minus negative 1 is negative 3 plus 1, which is negative 2, and we have the same difference, so we know we're good. And we can get the next term simply by doing 5x minus 3 plus the difference 2x minus 2 is equal to 7x minus 5. Circle our answer, put it in the diagram, 7x minus 5, circle your answer. And then the next term will just be that, 7x minus 5, plus the difference, 2x minus 2. 7x plus 2x is 9x. Negative 5 minus 2 is negative 7. Circle your answer, put it above, 9x minus 7. Finding terms in the future with polynomials. Okay, number 2. So, 2a, we have the terms t2 equals 8 and t4 equals negative 32. Okay, so we could set it up with our blanks, but we know that 8, term 2, plus the number of differences, 4 minus 2 equals 2, 2 differences, plus 2 differences is equal to negative 32. Okay, so we can solve minus 8, therefore 2d will equal negative 40, and divide both sides by 2, d equals negative 20. Then we can answer the question, so blank, comma, blank, comma, blank, comma, blank. It says find t1 and d. So we know t2 is 8, and we know t4 is negative 32, and we know d is negative 20. So these terms are going down by 20 each time. So 8, if I go down by 20, 8 minus 20 is going to be negative 12. And then if I minus 20 again, we get negative 32 check mark. If we want to go in the other direction, however, we need to do the opposite and add 20 and simply get 28. And there is our sequence. So, really remembering, a term in the future is equal to, a term plus a certain number of differences is equal to a term in the future. Understanding this formula will drastically diminish the amount of algebra you have to do. For example, I could have written the term formula twice. Tn equals a, or t1, plus n minus 1 d. Then I could start working with it. So I have t2. t2 is 8 equals a plus t2 is 8, so 2 minus 1 times d, the negative 20, that we don't know yet. We're going to pretend. So then I get 8 equals a plus 2 minus 1 is 1, so 1d, or d. And then I can use t4. t4 is negative 32 equals a, I'm missing a plus sign in the formula directly above. I'm going to clean that up. The formula a plus n minus 1d. So a, the first term, again, we don't know, plus I'm working on t4 from the given information, so 4 minus 1, d, again, we don't know d. Clean that up, negative 32 equals a plus 3d. Then we're going to isolate for a variable in the other equation. How about we isolate for d? So I'm going to minus a from both sides and mirror it. D equals 8 minus a. Circle what d is equal to. Put it in the other equation. Negative 32 equals a plus 3, open bracket, 8 minus a. Distribute. Negative 32. That's a 2 directly above. I accidentally wrote a D. I'm going to write that in red so everyone can see. equals a plus 24 minus 3a. So I can minus 24 from both sides. So we'll get minus 56 equals, then I can work on the a's. So a minus 3a is going to be negative 2a. Then we can divide both sides by 2. And then, divide both sides by negative 2 and then mirror it. A equals positive 28. We can then take that a value and put in the d formula off to the left. And 8 minus 28 is going to be negative 20. So as you can see, again, the algebra to do this by a systems of equations is going to be way more difficult than just understanding the formula that we used a bunch of times in question 1 and just now, and we're going to use again. So a term plus the number of differences is equal to a term in the future. And we're going to do that again right now. Okay, 2b, we have T3 equals 3 and T12 equals negative 1527. So we know we can take a term 3 plus the number of differences from term 3 to term 12. So we can do 12 minus 3 equals 9. The reason why I do this is, what if it was term 100? It's just very confusing, so you always want to do that subtraction just to be confident. Plus 9 differences is equal to negative 1527. If we minus 3 from both sides, 9d equals negative 1530. And then we can divide both sides by 9, and d equals 1530 divided by 9 is 170. So we have our d value, and now they want t1. So we could do it logically like we did before, where why we just do blank. So blank, comma, blank, comma, blank, t3 is 3. And because d is 170, we can just minus 170 and then minus 170. So 3 minus 170 is equal to negative 167. Minus 170 is equal to negative 337. Circle our answer. Therefore, T1 is equal to negative 337. Now, what if you like the formulas more? This won't involve a system, but T1 or Tn equals A plus n minus 1d. So we just decide which term we want to use. Why don't we use term 3? Term 3 is 3. Term 3 has an n value of 3. Therefore, 3 minus 1 times the d value, 170. Clean it up. 3 equals a plus 3 minus 1 is 2. 2 times 170 is equal to 340. And if we minus 340 from both sides and mirror the equation, a equals negative 337, as we got with the blanks using logic. So, very useful using the formula. A term in the future is equal to a term in the future plus a certain number of differences is equal to a term in the future. That will avoid having to use a systems of equations. I highly recommend learning that logistic formula. Okay. Okay, number 3. So we have a sequence 3, 5, 7. ... Okay, find the general term. So it gets kind of confusing with what they're looking for sometimes. Tn equals a or t1 plus n minus 1d. So sometimes they just want what Tn is equal to, a formula for Tn. Tn equals a3 plus n minus 1. Now we have to find d. Let's find d twice. D equals 7 minus 5 equals 2. D equals 5 minus 3 equals 2. Therefore, no d is 2. Therefore, Tn is equal to 3 plus, if I distribute backwards, 2n minus 2. And if I clean it up, Tn equals 2n plus 1. circle your answer. That is called the general term. Every term is Tn. Term 1 is Tn, where n is 1. Term 2 is Tn, where n is 2. So that is what's called the general term because it allows us to solve for every single term. Okay, so they're going to say, what's the 10th term? So we can say T10 equals 2n, I put n, 10 in for n on the left-hand side, so I have to put 10 in for n on the right-hand side. And T10 is equal to 20 plus 1 is 21. Circle our answer. Let's check our answer. 3, 5, 7, plus 2 is 9, plus 2 is 11, plus 2 is 13, plus 2 is 15, plus 2 is 17, plus 2 is 19, plus 2 is 21, our 10th term. Okay, now they're saying 31 is what term? That means that's a Tn. We're going to put that into the left-hand side of the equation. Let's write the equation down again, the general term from above. So this time 31 is a Tn. We're going to put it in for Tn. We either substitute for n or we substitute for Tn. So 31 equals 2n plus 1 if we minus 1 from both sides. 30 equals 2n if we divide both sides by 2. N equals 15. And it's the 15th term. Sorry, I was working there on B, question B. So what if I continue my sequence above to the 15th term? 21 plus 2 is 23, plus 2 is 25, plus 2 is 27, plus 2 is 29, plus 2 is 31, and that is the 15th term. Okay, it's saying what is the sum of the first 12 terms? So that's going to be C here. So let me do that on a new page. Okay, 3C continued from the last page. So it's asking for S12. So I'm going to write down both S formulas, which Gauss figured out when he was 15 years old. Sn equals n over 2, open bracket, T1 plus Tn. Notice I've just gone back and forth between A and T1. They are the same. A and T1 are the same. You can go back and forth between the two. So that's one of the formulas. The other formula is Sn equals n over 2, 2T1 plus n minus 1 d. So which one of these formulas do I want to use? Well, if I'm looking for the sum of the first 12 terms, A, B, B was above, this was C, and now we are working on 3D, So 3D says, what is the sum of the first 12 terms? So it's easier if I use the formula on the right. S12 equals 12 divided by 2, open bracket, 2 times the first term, 3, plus n minus 1, 12 in for n, times the difference that we found twice, 2. So S12 equals, clean it up, 6 times 6 plus 12 minus 1 is 11, times 2 is 22. And then on the calculator, 6 times 28, S12 equals 168. Now we could just add up the first 12 terms. 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus 23 plus 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Add up all those terms and you better get 168. It has to all logically make sense. So what if I wanted to use the other formula? Looks a lot simpler. Well, S12 equals 12 over 2. We know the first term, 3 plus But we don't know that term. That's T12. Then we'd have to find T12. So T12 would equal, from the formula, T1, 3 plus, I'm going to write the formula above. Notice I go back and forth between A and T1. 12 minus 1 times the difference D, which is 2. T12 equals 3 plus 11 times 2 is 22 plus 3 is 25. As we knew from above, then we'll take that. So then S12 will equal 12 over 2, or 6. 3 plus 25. And then 6 times 28, S12 equals 168. So you can use either of the two formulas for sums. However, one, you have to find the term, the last term of the sums that you're looking for. Again, you could check your answer by writing all the terms down and then adding them up. Okay, E. Find the number of terms if Sn is equal to 24. Okay, so a certain number of terms is going to add to 24. So, which formula do we want to use? We don't know what the last term is, so we want to use the formula on the right. Sn equals n over 2, 2t1 plus n minus 1 d. So again, we don't know what n is. So Sn is 24 equals n over 2. 2 times t1, so 2 times 3, plus, again, we don't know what n is. So clean that up. First of all, we've got a 2 on the bottom. We can times both sides by 2 and cancel those 2's. 48 equals n open 6 plus. Distribute backwards. Oh, I forgot to substitute d above. I'm going to erase that d and put in a 2 in red. Give you a second. Distribute backwards, plus 2n minus 2. Okay, so we have to then clean it up a bunch. So 48 equals n plus, so we're going to get 6 minus 2, n open bracket, 6 minus 2 is 4, plus 2n, then we'll distribute. So 48 equals 4n plus 2n squared. So we have to get this thing equal to 0. 0 equals 2n squared plus 4n minus 48. Oh my gosh, this is sequences. It's too much. I lied. This question is a grade 11 question, and we would need to do it in grade 11 or 12. So if you'd like to learn how to factor these things, I will end it there. Okay, I figured I'd solve it just for fun. So I'm going to bring that up in red up on the left there. So let's take 0 equals 2n squared plus 4n minus 48. Start by dividing the whole thing by 2. 0 equals n squared plus 2n minus 24. So this thing can be factored. So we can factor it to be n0 equals n minus 4, n plus 6, two numbers that multiply to get negative 24, and add to get positive 2 are negative 4 and positive 6. Then we can set our factors equal to 0 separately. N minus 4 equals 0 and n plus 6 equals 0. So then if we add 4 to both sides, n equals 4. And if we subtract 6 from both sides, n equals negative 6. By definition, we can't have a negative term number. Therefore, we know n is 4. And that's the sum of the first 4 terms. Let's check our answer. 3 plus 5 plus 7 plus 9 equals 24. Check mark. So sorry about that. I accidentally included a grade 11 question, but you never know. They might throw it at you. You know how to factor. You might have to extrapolate a little bit of your knowledge. All right, number 4. The following diagrams are made of toothpicks. So create a sequence and find the equation. So blank, comma, blank, comma, blank. How many toothpicks do we have in the first diagram? 4. How many toothpicks do we have in the second diagram? Well, we're only adding 3, so 7. How many do we have in the third diagram? Well, we're adding 3, so 10. Feel free to count them all. Okay, so find the equation. Let's find d twice. So d equals 10 minus 7 equals 3, and d equals 7 minus 4 equals 3. So then we can say Tn equals T1. Notice A and T1 can be completely interchangeable. T1 plus n minus 1 d. Therefore, Tn equals the first term, 4, plus n minus 1 times the d value we just got, 3. Distribute that backwards. Tn equals 4 plus 3n minus 3. Therefore, Tn equals 3n plus 1. Circle your answer. That is the equation for the number of toothpicks. You may have remembered from graphing off to the right, we used to make a table of values, x and y. Well, when x is 1 in the first diagram, we have 4 toothpicks. When x is 2 in the second diagram, we have 7 toothpicks. When x is 3 in the third diagram, we have 10 toothpicks. And that equation would simply be y equals 3x plus 1. So this stuff is not that new. We were still doing it before in graphing and finding the equation, just now it's called sequences and series. So find the number of toothpicks in the fifth diagram. So T5 equals 3 times 5 plus 1. Therefore T5 equals 15. 3 times 5 is 15 plus 1 is 16. And then we can make sure 4, 7, 10, 13, 16. We are absolutely correct. That was A was the general term, B was term 5, C is find the number of toothpicks in the 10th diagram. So now we can write down the equation again. Tn equals 3n plus 1. Just this time we are substituting 10 in for n. So T10 equals 3 times 10 plus 1. Therefore, T10 is simply 31. So, just making that connection between sequences and series and word problems and tables of values and graphs and y equals mx plus b, it is all linked and connected. Okay, number 5. Find x to be arithmetic. So we have x plus 2, we have 2x plus 1, and we have 4x minus 3. Okay, so find x to be arithmetic. Well, we know that we're supposed to find d twice first, every single time. So let's do that. D equals taking a term and subtracting the term before it. Again, setting it up, taking a term and subtracting the term before it. So d equals, if I distribute the negative, 2x minus x is x, and 1 minus 2 is negative 1. Therefore, we have a d value of x minus 1. Okay, d equals, distribute the negative, we're going to get 4x minus 2x. 4x minus 2x is 2x, and negative 3 minus 1 is minus 4. So we got a d value. We know our d value has to be the same. So we know our d value has to be equal to each other. So we can set them equal to each other and solve. So x minus 1 equals 2x minus 4. We can minus x from both sides. minus 1 equals x minus 4. Add 4 to both sides. Mirror it. X equals negative 1 plus 4 is 3. Circle our answer. Check our answer. So our first term says x plus 2. 3 plus 2 is 5. Our second term says 2x plus 1. 2 times 3 is 6, plus 1 is 7. Our third term is 4x minus 3. 4 times 3 is 12, minus 3 is 9. And we absolutely have a sequence with a difference of 2. Therefore, it fully makes sense. X is 3 is the answer. So remember, with those, we have to find an x to make it arithmetic. Therefore, taking a term, subtracting the term before it twice, and then making those equal to each other, solving for x, and then checking your answer. Okay, number 6. We have the terms 2, 6, 10, blank, blank, blank. So we can clearly tell that we're going up by 4 and that our terms are just 14 and 18 and 22, but we want to do it properly. So which sum formula do you want to use? Well, again, like before, you could use the t formula to find the sixth term and then find the sum of the 6 terms using the simpler formula, but let's use the more complicated formula so we don't have to bother using the other formula to find other things. So substituting the formula, S6 equals 6 over 2 times the first term 2 plus n6 minus 1 times d. d equals 6 minus 2 equals 4. Putting 4 in for d. Typing in the calculator, 6 divided by 2 is 3. 2 times 2 is 4, plus 6 minus 1 is 5, times 4 is 20. And we're going to get 4 plus 20 is 24, times 3 is 72. S6 equals 72. Check your answer. 2 plus 6 plus 10 plus 14 plus 18 plus 22 equals 2 plus 6 plus 10 plus 14 plus 18 plus 22 equals 72. As expected, check mark. So all sorts of different ways to do these questions. You don't always have to use the formulas. You can figure things out logically just for fun and then know what you have to shoot for with the formula. Okay, 7. So 7a. So we have 13, 15, 17, 19, 273. And it's saying finding n, the number of terms, and then find the number of terms. So we have the term formula, Tn equals T1 plus n minus 1 d. Let's find d. d equals 15 minus 13, taking a term and subtracting the term before it. Now, we know every term is Tn. We want to use the last term to be Tn and put 273 in for Tn. If that's really difficult, just like T1, T2, T3, T4, T we don't know, so Tn, so put it in for Tn. Equals the first term plus, we don't know what n is, times the difference we just figured out. Minus 13 from both sides, 260 equals, distribute backwards, 2n minus 2, add 2 to both sides, mirror it, 2n equals 262, divided both sides by 2, and then n equals 131, circle your answer. Therefore, 273 is the 131st term. Sometimes that helps. 273 is the 131st term. So when you're going back and you're studying your stuff, it gets a lot simpler. Everyone gets so upset with what we should substitute for. Are we substituting for n or are we substituting for Tn? Just get really calm. Is it a term or is it a term number? Do we substitute for n or do we substitute for Tn? So be very careful with that. Okay, let's do that again. Okay, 7b. So we have 8, comma, negative 6, comma, negative 20, dot, 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 negative 160. So our formula, first of all, let's find d. d equals negative 6 minus 8 equals negative 14. Terms going down by 14. So Tn equals T1 plus n minus 1d. Therefore, this time we have Tn being negative 160 equals T1 being 8 plus n minus 1 times the d value, negative 14. Cleaning it up, negative 160 equals 8 minus 24n plus, 14 minus 14n plus 14. So clean it up even more. Negative 160 equals 8 plus 14 will be 22 minus 14n. If we minus 22 from both sides, negative 160 minus 22 will be negative 182 equals negative 14n. And if we divide both sides by negative 14, n equals 13, and we have the 13th term. Okay, number 8. So if you have a signing bonus of $10,000, then make $36,000 in your first year of work, then get a raise of $3,000 per year. That means in the second year we're going to make $39,000. And the third year, we're going to make $42,000. So it says, how much are you make in your 10th year? Well, that's T10. So T10 equals. Now, what are our sequences? What's our first term? 36,000 is T1, 39,000 would be T2, and 42,000 would be T3. This $10,000 signing bonus is a red herring to throw you off. You make that just for signing up. You could quit that day. So D is simply going to be the 3,000, the amount, the terms that are going up by, or your raise each year. So Tn will equal our formula, T1 plus n minus 1 d. How much we make in the 10th year? T10 equals our first term, 36,000 plus 10 minus 1 times d. Therefore, T10 equals 36,000 plus 10 minus 1 is 9. 9 times 3 is 27. 27,000. T10 equals 36,000 plus 27,000 is 63,000, and you will make $63,000 in your 10th year at work given that scenario. Don't get confused with the red herrings. Okay, that was the first part of the question. The second part of the question says, how much will you make total after 10 years? So that's S10. So Sn equals. Now, we've already calculated Tn, so we may as well use the simpler formula. n over 2, open bracket, T1 plus Tn. So S10, the total we're going to make, is going to be n, 10 divided by 2, T1, our first term of our sequence, T10, 63,000. So that's going to be 36,000 plus 63,000 is 99,000. 10 divided by 2 is 5, so 99 times 5 is going to be S10 equals 495,000. But the question said, how much are you going to make in the first 10 years? And we have to add the signing bonus of 10,000 to get a final answer of $505,000 in our first 10 years. Get some units on there, dollars. So a great question for arithmetic sequences in a series, thinking about how much you're going to make in the future with that little bit of a red herring. Don't let those red herrings throw you off. Okay, number 9, Sn equals 72, D equals 4, T1 equals 2, N equals question mark. So we have Sn information, so we're going to use the formula without Tn. And substituting in, we have Sn, that is 72. N divided by 2, we don't know what n is. T1 is 2. Again, we don't know what n is. Times our d value of 4, clean it up. Times both sides by 2. Therefore, 144 equals n times 4 plus 4n minus 4. Clean it up. 4 minus 4 is gone. Distribute. 144 equals n times 4n is 4n squared. Divide both sides by 4. Divide both sides by 4. Mirror it. N squared equals 36. Let me check that work. 144 divided by 4, 36. Good. Square root both sides. N equals plus minus the square root of 36 is 6. And we can reject the negative, therefore n equals 6. And we can check our answer. So if our first term is 2, and we're going up by 4, we'll get 2 plus 6 plus 10 plus up by 4, 14, plus up by 4, 18, 1, 2, 3, 4, 5, one more term, plus 22, better equal 72, check mark. So that question is a much more likely question where you just have to square root both sides rather than factor it. In that question that I mentioned was a grade 11 question, so this one's much more grade 10, so just be careful when they do throw those idiosyncrasies from the higher grades that you sort of have to figure out what to do on your own. And we know how to square root both sides from Pythagoras in grade 8, so that would be the method here. Okay, number 10. So with this time we have S2 equals 9 and S3 equals 21. Find the first 5 terms. So we need 5 terms. Blank, comma, blank, comma, blank, comma, blank, comma, blank. That's the goal, all 5 terms. Now, S2 is 9 and S3 is 21. So there is some very interesting systems of equations that you can do with both equations, but we want to think about it differently. S2 is the sum of the first 2 terms. That means that T1 plus T2 equals 9. S3 is the sum of the first 3 terms. T1 plus T2 plus T3 equals 21. Now we know T1 plus T2 is 9, therefore we can put 9 in for T1 plus T2. 9 plus T3 equals 21. We can then solve. Minus 9 minus 9, T3 therefore equals 21 minus 9 is 12. So now we have T3, T3 is 12. Okay, now we have to work backwards. Let me think about this for a moment. Okay, I can't figure out what the algebraic solution is at the moment, but T1 plus T2 must equal 9. So what could the terms be? They could be 1, then 8. They could be 2, then 7. They could be 3, then 6, etc. Now, which one of these sequences works with 12 next? Well, 1 plus 7 is 8 plus 7 is 15. No. 2 plus 5 plus 5 is 12, therefore we know we're good there. And we can put 2 and then 7. Then we know that D is equal to 7 minus 2 or 12 minus 7 are both 5. We can just go up by 5 each time. Top right, 12, 17, 22. Circle your answer, finding the first 5 terms. So notice we did that with only, not guess and check, but some kind of logic. So knowing that the first 2 terms added up to be 9, deciding on what those terms could be, then using the next term that we figured out, using an interesting form of substitution, and then solving the question. Okay, number 11. T2 plus T3 equals 20, and S2 equals 12. So let's start on the equation on the right. So S2 is the sum of the first 2 terms, T1 plus T2 equals 12. So we know that T2 is just T1 plus D. So T1 is simply T1, then substituting for T2 plus T1 plus D equals 12. Therefore, 2T1 plus D equals 12. Working on the equation on the left, so T2 is just T1 plus D, and T3 would just be T1 plus 2 differences. So we've got 2 equations with 2 unknowns. We can clean it up. T1 plus T1 is 2T1. D plus 2D is plus 3D equals 20. So we have 2 equations, 2 unknowns we can solve. Let's isolate for D in the equation on the left, or you know what? Let's eliminate. So you may or may not have learned how to eliminate yet. You know what? Let's do both. So in the equation on the right, I'm going to subtract 2T1 from both sides. Therefore, D equals 12 minus 2T1. I can then take that and put it in for D in the other equation. 2T1 plus 3 open bracket, 12 minus 2T1 equals 20. Clean it up. 2T1 plus 36 minus 6T1 equals 20. Minus 36 from both sides. The right-hand side, 20 minus 36 is negative 16. 2T1 minus 6T1 is negative 4T1. Divide both sides by negative 4. And then therefore T1 equals 4. Circle your answer. We have a nice equation off to the right to find D. D equals 12 minus 2 times 4. D equals 12 minus 8 is going to be 4. Therefore, if our first term is 4, we're going up by 4. Our next term is 8. And the sum of the first 2 terms is definitely 12, so that's good so far. And then our next term would be 12, and T2 plus T3 are 8 plus 12 is 20, which are both correct. Very interesting questions. A lot of algebra, a lot of manipulation to solve for what we're looking for. Okay, 12a, a little bit on summation notation. So we have k equals 1 to 5 of the formula 3k equals. So what that means is we have blanks. And for the first term, we're going to put 1 in for k. So if the formula is 3k, 3 times 1 is 3. Then we're going to put 1 more. So this was when k equals 1, then k equals 1 more than that, 2, all the way until k equals the top number. So if we put 2 in for k, we're going to get 6. If we put 3 in for k, k equals 3 and k equals 4. If we put 3 in for k, we're going to get k equals 9. Then if we put 4 in for k, we're going to get 12. If we put 5 in for k, we're going to get 15. Notice after we got the first 2 terms, 3 and 6, we knew it was going up by 3, therefore we could have just added 3 each time. Now this actually means find the sum of the first 5 terms. So we got 5 from the top number minus the bottom number plus 1 equals 5. Now that may seem obvious to you, but what if the bottom number is not 1? Okay, so we have to find S5. So S5 equals. Now notice I could use the simple formula or the harder formula. I'm going to use the simpler formula this time. N over 2 T1 plus Tn. But I have to find the fifth term. So I have to find Tn. So Tn is the equation that's given. Notice k and n are interchangeable here. So T5 equals 3 times 5 equals 15, like we found out with logic. So S5 equals 5 over 2, the first term 3 plus the last term 15. S5 equals 3 plus 15 is 18. 18 times 5 over 2. 18 times 5 over 2 is going to be 45. And we could check our answer. 3 plus 6 plus 9 plus 12 plus 15 is indeed 45. Check mark. 3 plus 6 plus 12 plus 15 is indeed 45. Check mark. Great, so summation notation means find the sum of the terms. And that's 12a. Okay, 12b. So, summation notation, k equals 2 at the bottom. It might be any letter, I or n or whatever it is, doesn't matter. 2k minus 1. So now that's our equation, 2k minus 1. So if we set up our terms, we're trying to find the sum of how many terms? Well, as I mentioned before, we take the top number minus the bottom number and add 1. 5 minus 2 is 3, plus 1 is 4. Therefore, we have 4 terms. So we have to find the sum of the first 4 terms. Let's use the more complicated formula. N over 2, open 2t1 plus n minus 1d. So we don't have to find the fourth term. But we're going to have to find terms anyways. So S4 equals 4 over 2, open bracket 2. Now what is T1? Well, T1 is putting 1 into the equation. So 2 times 1 minus 1. T1 is 2 minus 1 is 1. So times 1 plus 4 minus 1. Now we have to find D, which means we have to find the second term. T2 equals, putting 2 in for k, 2 times 2 minus 1. T2 equals 4 minus 1 is 3. Therefore, D equals 3 minus 1 equals 2. Therefore, S4 equals 4 divided by 2 is 2. 2 times 1 is 2. Plus, oh, I forgot to substitute D in. I'm going to erase that and put it in red above. 4 minus 1 is 3 times 2 is 6. Therefore, S4 is equal to 2 plus 6 is 8 times 2 is 16. So summation notation just means find the sum, or they've given you the sum.